Let's look at some classical purification methods. Imagine you have some oil and water in a test tube, but you just want the oil. How would you obtain it? Well, you could simply decant it off by just tipping it out and trying to not get out the water. This will work pretty well until you get near the meniscus here, at which point you're probably going to get a mixture. There are devices known as separatory funnels, which allow you to separate it out the bottom. You'll need a stopcock here, and you just hit that thing to close once the bottom layer comes out, and then you would have the pure oil. Imagine you have some wet sand, but you don't want that. You want some dry sand. Now you might think, oh, I could just simply let it evaporate. That would not work very well because it would precipitate out anything that was dissolved in that salt, which is likely anything dissolved in that liquid mixture, which might have a lot of salts in it, for example, if it were ocean water. Better to simply filter it, which means run it through some filter paper by gravity, rinse it a bunch of times with water, and in right there should be, once you've rinsed it a few times, some nice pure sand. Let that evaporate, the water goes off, and you've got the dry sand. You have a mixture of sugar and water, but you only want the sugar. Here, evaporation is a pretty good idea, but you might not want to go to dryness. Once again, if there's some impurities, they will certainly precipitate it out if you let the thing evaporate fully. If you let it evaporate partially, you will get initially some beautiful crystals that are almost certainly very, very pure. So rather than let it evaporate to dryness, filter at that point, and you should have nice crystallized sugar. This process is known as crystallization. You got a bunch of oils, but you want each pure substance in that liquid-liquid mixture. Well, like all these methods, you're looking for some method to separate them, some physical properties that vary. A good example in this case would be their boiling points. Each oil is likely to have a slightly different boiling point, so you take advantage of that by a process known as distillation. Stick it in a pot, heat it up until the lowest boiling compound boils, rises up the column, registers its boiling point at this thermometer here. It's in the gaseous phase, since after all it boiled. But you don't want to just have it evaporate, just smoke out, right? So you just have the gases exiting. So you cool that column with some cold water. Since that process is known as condensation, that's a condenser. And then let each liquid drip out. Change flasks frequently here, and you have distilled off each pure liquid. If you have some sort of solute dissolved in a solvent, like ink and water, and you'd like each one, chromatography is a great method here. Simply spot that mixture onto a piece of paper or something more efficient. Elute it up by adding a little solvent to the bottom of a container like a beaker. Let it rise up, and typically each substance will have a different adhesion to the paper or whatever that stationary phase is, and you can effect separation that way. Decanting, filtration, crystallizing, distillation, and chromatography, these are some classic purification methods.